The question is, which one of the following matrices has an inverse? 4 options given: A, B, C, D. This question is from engineering mathematics, from linear algebra, subtopic basics, 1 mark question. The solution is, so if determinant of a given matrix is not equal to 0, then only that matrix has an inverse. So in each option, find the determinant. Option A, determinant 1, 4, 8, 0, 4, 2, 0.5, 2, 4. So here R1, R3 are proportional. R1 is equal to 2 times of R3 is equal to 0, since R1 row 1 elements is equal to correspondingly 2 times of the elements of R3. That is implies R1, R3 are proportional. So this matrix has no inverse. Next, B. Determinant 1, 2, 3, 2, 4, 6, 3, 2, 9. So this is also equal to 0 since R1 and R2 are proportional. Since R1, R2 rows are proportional. R2 is equal to 2 times of R1. C. Determinant 1, 4, 8, 0, 4, 2, 1, 2, 4. Now expand the determinant here. No 2 rows, no 2 columns are proportional. 1 into 4 into 4, 16 minus 2 into 2, 4. Minus determinant expanded by any row or any column. Here I am expanding by first column. Minus 0 into anything is 0. Plus 1 into this 1 into deleting third column, first column, third row, deleting 4 into 2, 8 minus 8 into 4, 32. So 8 minus 32. So this value not equal to 0. Here you will be getting minus 24. Here 12. Okay. 12 minus, this is 12 minus 24. Minus 12 not equal to 0. Therefore, the matrix 1, 4, 8, 0, 4, 2, 1, 2, 4 has an inverse. Similarly, determinant to D also. D matrix, that is the matrix in the option D. Determinant 1, 4, 8, 0, 4, 2. We got the answer in option C because they are in the question it was asked one of the following matrix only. 3, 12, 24 is equal to 0 since R3 is equal to 3 times of R1. So the answer is option C. This is the end of the question. The question is, let X be a discrete random variable that is uniformly distributed over the set minus 10, minus 9, so on 0, comma, so on 9, comma 10. Which of the following random variables is or uniformly distributed? 4 options given. This is from engineering mathematics, from the topic probability and statistics. Subtopic distributions, discrete distribution. And this is one more question. The solution is here the number of elements from minus 10 to 10 continuous numbers are there, integers, 21 numbers, 21 outcomes. The set, the random variable X has 21 outcomes. So no, nothing is repeated. So each outcome has the probability 1 by 21. Okay. So given X is equal to minus 10, minus 9, so on, 0, so on, 9 comma 10 is a discrete uniformly random variable with probability of each outcome is 1 by 21. Total elements in the random variable X is 21. Nothing is repeated. So if each outcome has the same probability, that random variable is a discrete random variable. Discrete uniformly random variable. Uniform means each outcome has the same probability. Now, option A, X square. Square of each outcome, minus 10 whole square 100, minus 9 whole square is 81, minus 8 whole square 64, so on. 2 minus 2 whole square 4, minus 1 whole square is 1, 0 square is 0, 1 square is 1, 2 square is 4, 3 square is 9, so on. 8 square 64, 9 square 81, 10 square 100. So here 100 is repeated 2 times, 81 is repeated 2 times. So some of the outcomes are repeated. Okay, 0 is not repeated. Remaining all outcomes are repeated. Is not a uniformly random variable because probability of the outcome 0 is 1 time 1 by 21. Total outcomes 21. Probability of the outcome 1 is repeated 2 times 2 by 21. So these two are not same, which is not uniform. Okay. Now B, X cube. Minus 10 cube is minus 1000. Minus 9 cube is minus 729. Minus 8 cube is minus 512. So on. Minus 2 cube is minus 8. Minus 1 cube is minus 1. 0 cube is 0. 1 cube is 1. 2 cube is 8. So on. 9 cube is 729. 10 cube is 1000. So nothing is repeated here. It is a uniform random variable. Is a uniformly random variable next C, option C. First we have to find X minus 5. Subtract 5 from each outcome of the random variable X to get the random variable X minus 5. Okay, so this is minus 15, minus 14, minus 13, so on, minus 5, so on, 3, 4, 5. Implies X minus 5 whole square is equal to minus 15 square is 225, minus 14 square 196, and minus 13 square 169, so on, minus 6 square is 36. 5 square minus 5 whole square is 25. 4 square is 16. So on. 3 square 9. 4 square 16. 5 square 25. So here 25 is repeated 2 times. 16 repeated 2 times. 225 is not repeated. So this is not a uniformly random variable. Uniform random variable. Not a uniform random variable, as probability of the outcome 225 is 1 by 21. Total number of elements in the set x minus 5 whole square is 21. Probability of 25 outcome 25 is repeated 2 times. So probability of 25 is 2 by 21. Next. Option D. X plus 10 whole square. So first find x plus 10. Add 10 to each outcome of the 10, to each outcome of the random variable x. You will be getting 0, 1, 2, so on, 10, so on, 9, 10 is a discrete uniformly random variable as each outcome is same 1 by 21. But they're asking x plus 2 whole square. Is equal to 0, 1, 4, 2 square 4, 3 square 9, so on, 10 square 100, so on. This is 1920. Kindly excuse me, x plus 10. Nineteen 20. 19 square 361. 20 square 400. Here no element is repeated. So this is a implies is a uniformly random variable. So the question requires which of the following random variables is uniformly distributed. Accordingly, option B and option D. Therefore, options B, comma D. So this is the answer. This is end of the question. The question is, which of the following complex functions is or analytic on the complex plane? 4 options ABCD given. This is from engineering mathematics from the topic complex variables, subtopic analytic functions, which is 1 mark question. The solution is so in all this, let us take the complex variable z is equal to x plus jy and the analytic function f of z. F of z is the analytic function. I mean f of z. In each option we have to show whether it is analytic or not. So let us take f of z is u plus jv, where u is real part, v is analytic imaginary part. U is real part of f of z, v is imaginary part of f of z. Then Hmm. Option A, f of z, j into real z. So real z, that is real part of z is x only. So j into x. So from this, comparing with u plus jv, you will be getting real part of f of z 0 and imaginary part is x. Check whether CR equations are satisfied or not. Dou u by dou y 0, dou v by dou x is equal to 1. Implies dou u by dou y not equal to minus dou v by dou x. That is Cauchy-Riemann equation. CR equations are not satisfied. Therefore, f of z is equal to j times real part of z is not analytic on the complex plane. Next, f of z is equal to imaginary z. Imaginary z means y. So from this, real part u is equal to 0, u is equal to y. Imaginary part v is equal to 0. So find dou u by dou y 1, dou v by dou x 0. So from this, dou u by dou y not equal to minus dou v by dou u by dou y not equal to minus dou v by dou x. That is CR equations fail. Cauchy-Riemann, one of the Cauchy-Riemann equations fail. Therefore, f of z is not analytic. She. F of z is equal to e power mod z value is root over x square plus y square. So comparing with u plus jv, you will be getting u real part is e power root over x square plus y square, v imaginary part 0. From this, dou u by dou x. E power x derivative is e power x, e power root over x square plus y square derivative is e power root over x square plus y square. With respect to x, root x derivative is 1 by 2 root x square plus y square into, with respect to x partially derivative is 2x. So this is dou u by dou x and dou v by dou y is equal to 0 implies dou u by dou x not equal to dou v by dou y. That is the CR equation not satisfied. CR equations are not satisfied. Implies f of z is equal to e power mod z is not analytic and f of z is equal to option D. F of z is equal to z square minus z. This is a not required to separate u and v, imaginary part and real part. This is a general polynomial function. Second degree polynomial function is a polynomial function in Z Therefore, f of z is analytic for every z on the complex plane. Okay. Therefore, option D is the answer. The answer is option D. This is end of the question. The question is, consider the complex function f of z is equal to cos z plus e power z square. The coefficient of z power 5 in the Taylor series expansion of f of z about the origin is round off to one decimal place. This question is from engineering mathematics from the topic complex variable subtopic Taylor series. This is one more question. The solution is we know standard Taylor series expansion about the origin for cos z function and e power z function. So that we will be getting e power z. Cos z is equal to 1 minus z square by 2 factorial plus z power 4 by 4 factorial z power 6 by 6 factorial even function. All powers of z must be even and e power z is equal to 1 plus z by 1 factorial plus z square by 2 factorial plus z cube by 3 factorial plus so on. From this, e power z square is equal to z is replaced by z square 1 plus z square by 1 factorial z square whole square z power 4 by 2 factorial plus z power 6 by 3 factorial plus so on. Here 1 factorial. This is one factorial. Now, are the Taylor series expansions about the origin therefore that is about the origin means that is z is equal to 0. That is about z is equal to 0. Therefore, f of z is equal to the given function is cos z plus e power z square. Just adding 1 minus z square by 2 factorial plus z power 4 by 4 factorial minus z power 6 by 6 factorial plus so on plus 1 plus z square by 2 factorial z square by 1 factorial plus z power 4 by 2 factorial z power 6 by 3 factorial plus so on. So here all both brackets containing even powers of z. There is no z power 5 term. So coefficient of z power 5 is definitely 0. Therefore, coefficient of z power 5 in the above expansion is 0. So the answer is 0. This is end of the question. The question is, The sum of the eigenvalues of the matrix A is equal to 1, 2, 3, 4 square is dash. Round off to the nearest integer. This is from engineering mathematics from the topic linear algebra, subtopic eigenvalues, which is one more question. The solution is first simplify the matrix A. A is given square of this matrix, that is 1, 2, 3, 4 multiplied by itself 1, 2, 3, 4. First row into first column 1 into 1 plus 2 into 3, 6 plus 1, 7. First row multiplied by second column 1 into 2, 2 plus 2 into 4, 8. 2 plus 8, 10. Second row multiplied by first column 3 into 1 plus 4 into 3, 12 plus 3, 15. Second row multiplied by second column 3 into 2, 6 plus 4 into 4, 16. 6 plus 16, 22. Okay. The question requires sum of the eigenvalues. According to the properties of eigenvalues, sum of the eigenvalues of the matrix is equal to trace of that matrix. Okay. Sum of the eigenvalues of the matrix A is equal to trace A using properties of eigenvalues. So, which is equal to trace A is equal to sum of the diagonal elements 7 plus 22 is equal to 29 using properties of eigenvalues. So the answer is 29. This is end of the question. The question is, consider a vector u bar is equal to 2x cap plus y cap plus 2z cap, where x cap, comma y cap, comma z cap represent unit vectors along the coordinate axis x, comma y, comma z respectively. The directional derivative of the function f of x, comma y, comma z is equal to 2 log xy plus log yz plus 3 log xz at the point x comma y comma z is equal to 1 comma 1 comma 1 in the direction of u bar is. Four options given. This is from engineering mathematics from the topic calculus, subtopic vector calculus. Thus, which is a 2-mark question. The solution is, so to find the directional derivative, two important steps. Find the gradient for the given scalar function, that is del f, and find the unit vector in the given direction u bar. Here, in place of I bar, j bar, k bar unit vectors, they are given x cap, y cap, z cap. That is the difference. And we know that log mn is equal to log m plus log n. So, given f of x comma y comma z is equal to, using properties of logarithms, 2 into log x plus log y plus this is log yz is log y plus log z plus 3 into log x plus log z. So, this is simplifies to 2 log x plus 3 log x, 5 log x, 2 log y plus log y, 3 log y, log z plus 3 log z, 4 log z. Now, implies grad f gradient of the scalar function f is equal to x cap dou f by dou x plus y cap dou f by dou y plus k cap dou f by dou z plus k cap means z cap here. So this is equal to x cap into partial derivative with respect to x, y0, z0, yz are constants. So they become 0. 5 log x derivative 5 by x. Log x derivative with respect to x is 1 by x plus y cap into dou f by dou y. With respect to y partial derivatives log x, log z constants 0. So 3 log y derivative 3 by y plus z cap into with respect to z partial derivative log x log y constants. So constant derivative 0, log z derivative 1 by z. So this is 4 by z. At the point P 1 comma 1 comma 1. So this simplifies to substitute x equal to 1, y equal to 1, z equal to 1. 5x cap plus 3y cap plus 4z cap. Next, and E cap, that is unit vector in the given direction u bar by mod u bar. So this is 2x cap plus y cap plus 2z cap divided by length of this unit vector 2 square plus 1 square plus 2 square. So this simplifies to 1 by 3 into 2x cap plus y cap plus 2z cap. Therefore, required directional derivative is E cap dot grad f. So this is equal to 1 by 3 into dot product of E cap and grad f. 5 into 2 plus 3 into 1 plus 4 into 2. So this is 10 plus 3, 13 plus 8, 21 by 3 is equal to 7. So therefore, option B. So the answer is option B. Oh, sorry. So the answer is option C. 7 is in option C. So the answer is C. This is end of the question. The question is, let f of t be a real valued function whose second derivative is positive for minus infinity less than t less than infinity. Which of the following statements is or always true? A. F of t has at least one local minimum. B. F of t cannot have two distinct local minima. C. F of t has at least one local maximum. D. The minimum value of f of t cannot be negative. This question is from engineering mathematics from the topic calculus, subtopic maxima minima. This is 2 marks question. The solution is whose second derivative is positive already given. Okay, given f double dash t second derivative greater than 0 for minus infinity less than t less than infinity. Therefore, when second derivative greater than 0, the function f of t has local minima. When second derivative greater than 0, the function has local minima. When the second derivative less than 0, the function has local maxima. So therefore, f of t has at least one local minimum. Therefore, the answer is option A. This is end of the question. The question is, consider the function f of t is equal to square of the maximum of 0 comma t for minus infinity less than t less than infinity, where maximum of a comma b denotes the maximum of a and b. Which of the following statements is or true? F of t is not differentiable, f of t is differentiable and its derivative is continuous. F of t is differentiable but its derivative is not continuous. F of t and its derivative are differentiable. This question is from engineering mathematics from the topic calculus, subtopic limits continuity derivative, which is 2 marks question. The solution is, so given f of t is equal to maximum of 0 comma t whole square for minus infinity less than t less than infinity. From this can be written as, this can be divided into 3 cases. When t less than 0, t greater than 0, t equal to 0. When t less than 0, t negative, then maximum of 0 comma negative is 0. So 0 for t less than 0. When t is equal to 0, 0 comma 0 maximum is 0 for t is equal to 0. When t greater than 0, 0 comma t greater than 0 is positive. 0 comma positive maximum is positive only. So in this case t for t greater than 0. This first function is maximum of 0 comma t. We have maximum of 0 comma t. So from this, f of t is equal to square of the function of maximum of 0 comma t, square of the function maximum of 0 comma t. So this is 0 square is 0 for t less than 0, 0 square is 0 for t is equal to 0, t square for t greater than 0. From this, the t less than 0, t equal to 0 has the same function value. This can be written as 0 for t less than or equal to 0, t square for t greater than 0. This is the final function. So usual derivative f dash t, f double dash t find in this type of function defined in different subintervals implies f dash t, first derivative. 0 derivative is 0 for t less than or equal to 0, t square derivative 2t for t greater than 0. So what is here? F dash t is equal to 0 to t. When t less than 0, that is called left hand derivative. So left hand derivative of f of t is 0. Right hand derivative of f of t at t is equal to 0 is 2t. And f double dash t, one more derivative. 0 derivative is 0 for t less than or equal to 0. 2t derivative 2 for t greater than 0. So here, right hand derivative of f of t, that is f dash t value when t greater than 0. When t right hand derivative means, right hand derivative of f of t at t is equal to 0 means, that is f dash t is equal to 2t when t greater than 0 and t tends to 0, this value becomes 0. L f dash 0. That is, what is L f dash 0? the left hand derivative of the function f of t at t is equal to 0. That is f dash t value when t less than 0. This is the meaning. When t less than 0 and t equal putting then putting t is equal 0, 0. LF dash 0, this is 0. And RF dash 0 is nothing but derivative of f of t in the case of right hand method, right hand derivative of f of t, that is f dash t value when t greater than 0 and then t is equal to 0. So 2 into 0 is equal to 0. Okay. So LF dash 0 is equal to RF dash 0. So therefore f of d is differentiable at t is equal to 0. Next, L f double dash 0. That is left hand derivative of f dash t. That is f double dash t value when t less than 0. So that is 0. And R f double dash 0. That is right hand derivative of f dash t at t is equal to 0. Right means when t greater than 0, that the second derivative value is 2. So at t is equal to 0, this 2 is nothing but 2 only, which implies LF double dash 0 not equal to RF double dash 0. So therefore f dash t is not differentiable at t is equal to 0. What is f dash t? Derivative of f of t. So which implies derivative of f of t is not differentiable, DIFF means differentiable at t is equal to 0. Okay. Now f of t is not differentiable. Derivative of f of t is not differentiable. Where we have derivative of f of t is not differentiable. We have here already f of t is differentiable. Its derivative is not continuous. Okay. So not required to check here LF double dash 0, RF double dash 0. They asked f of t is differentiable and its derivative is not continuous. Now LHL left hand limit of f dash t at t is equal to 0. That is limit of the function f dash t when t tends to 0 from the left hand side, that is t less than 0. When t less than 0, what is the function value? 0. So limit of 0 is itself 0. Next, RHL, right hand limit of f dash t at t is equal to 0. When a function defined in different subinterval, we have to proceed left hand limit and right hand limit procedure to say the limit exists or does not exist. So here limit f of f dash t, t tends to 0, right means t greater than 0. When t greater than 0, f dash t value 2t. So this is 2 into 0, 0. So in this, left hand limit is equal to right hand limit is equal to 0, and this is function value at first derivative value at t is equal to 0, f dash 0. See in this, f dash 0. In the first case, when we put t is equal to 0, you will be getting f dash 0 is equal to 0. So therefore, f dash t is continuous at t is equal to 0, implies derivative of f of t is continuous at t is equal to 0. So f of t is differentiable at t is equal to 0. Derivative of f of t is continuous at t equal to 0. Okay. F of t is differentiable and derivative is continuous. So not required to find this part. This part is not required. Similarly, this part is not required. Okay. So the answer is option B. This is end of the question. The question is, which of the following differential equations is or non-linear? A. T dx by dx of t plus dx of t by dt is equal to t square e power t, x of 0 is equal to 0. B. Half into e power t plus x of t into dx by dt is equal to 0, x of 0 is equal to 0. C. X of t cos t minus dx by dt sin t is equal to 1, comma x of 0 is equal to 0. D. X of t plus e power dx by dt is equal to 1, comma x of 0 is equal to 0. This question is from engineering mathematics from the topic differential equation and the subtopic first order linear equations, first order equations, which is 2 marks question. The solution is so a differential equation is said to be linear if the dependent variable and its derivatives have degree 1 and these terms are not multiplied together. Otherwise, the differential equation is called non-linear. Okay. A differential equation, DE stands for differential equation. E is said to be linear if the dependent variable and its derivatives have degree 1 and these terms are not multiplied together. Otherwise, the differential equation is called, the DE is called non-linear. So, first A, option A. Here the dependent variable is x, t is independent variable, x power 1, its derivative dx by dt have power 1. These terms are not multiplied. So, linear differential equation, option A. Next, option B. The dependent variable x is multiplying with its derivative. The dependent variable x is multiplied with the derivative dx by dt. Therefore, the differential equation in B is non-linear. C. X of t cos t. Here the dependent variable is x derivative dx by dt have power 1 and these two terms are not multiplied. So, linear differential equation in option D. Dx by dt, e power dx by dt is a non-linear term. E to the power dx by dt is non-linear term because e power dx by dt is 1 plus dx by dt plus dx by dt whole square by 2 factorial using Taylor series expansion. So that derivatives have different powers. Okay. Continuously, all the powers getting, we cannot define. So this is a non-linear term. Therefore, the differential equation is non-linear. DE is non-linear. Okay. So they ask a non-linear. Option B and option D. So the answer is option B, option D. This is end of the question.